Welcome back. So we continue the discussion from the previous lecture. So from the previous lecture, remember that an nth order ordinary differential equation in one dependent variable is written in the form capital F of x comma y, y prime, y double prime, all the way up to the nth derivative equals to 0, where capital F is a real valued function of n plus 2 variables x, y, y prime, y double prime, all the way up to the nth derivative. Now let's call this one star. Now the differential equation nth derivative of y with respect to x written as x, y, y prime, y double prime, all the way up to n minus 1 prime, where f is a real valued function that is continuous is called the normal form of the equation star. Thus, when it suits our purpose, we shall use the normal forms dy dx equals to f of x, y, and we can also say d squared y dx squared is f of x, y, and then y prime. Or d power 3y dx squared is a function of x, y, first derivative, and then second derivative. So that was just by the way from our earlier discussion. Now, back to the classification on linearity, we say an nth order ordinary differential equation star is said to be linear if capital F is linear in y y prime, y double prime, all the y up to the nth derivative of y. So this means that an nth order derivative or nth order ordinary differential derivative is linear when star is a n of x d power ny dxn plus a n minus 1 of x n minus 1y dx power n minus 1 plus a n minus 2 of x dn minus 2 dy dx power n minus 2 all the way plus a1 of x dy dx plus a naught of x y equals to g of x. So two important special cases. Let's call this one equation 1. Of 1 are linear first order when n equals to 1 and linear second order when n equals to 2 differential equations. These are a1 of x dy dx plus a naught of x y equals to g of x, and then we have a2 of x d squared y dx squared plus a1 of x dy dx plus a naught of x y equals to g of x. So this is first order, this is second order. You can as well define third order, fourth order, etc. And then a nonlinear differential equation ordinary differential equation is simply one that is not linear. And then so we can say nonlinear functions of the dependent variable or its derivatives, such as sine of y or e raised power x, cannot appear in a linear equation. So to see this one, examples, the following are linear, first, second, and third order ordinary differential equations. These equations are 1, y minus x dx plus 4xy dy equals to 0. Number 2, y double prime minus 2y prime plus y equals to 0. Number 3, x cubed this cubed y dx cubed plus x dy dx plus 5y equals to e raised power x. All these are linear. But the following are nonlinear. So if I have 1 minus y dy dx plus 2y equals to e raised power x, so the nonlinearity comes from the fact that, so this variable y, the coefficient of dy dx, so nonlinear term coefficient depends on y. So remember, if coefficient depends on y, then that is a nonlinear equation. And then 2, another example, d squared y dx squared plus sine of y equals to 0. So here, this is the nonlinear term. Nonlinear term, nonlinear function of y. And then another example, d power 4y dx power 4 plus y squared equals to 0. This is also nonlinear. So power of y is more than 1. So just in summary, a differential equation is said to be linear if there's some conditions that actually should be taken for you to conclude that what you have is linear. 1, the dependent variable and its derivatives occur to the first power only. That's condition 1. Number 2, there are no products involving the dependent variable with its derivatives. And then the other one, there are no nonlinear functions of the dependent variable, such as sine, exponential, etc. So if an equation is not linear, then it is said to be nonlinear. So from this summary that we are giving about linearity of a differential equation, so note that from 2, second condition we are giving in this summary, that a product of terms involving the dependent variable such as y dy dx is nonlinear, but x dy dx is linear. And then from 3, that the existence of terms such as e raised power y squared sine y causes the equation to be linear, equation to be nonlinear, but e raised power x, y just power 1, and sine x are linear, assuming y is a dependent variable. So with this summary, if we have an equation like sine x dy dx plus y equals to x, we see that here dependent variable is y, so this is linear. And then number 2, if we have dx dt plus x equals to t cubed, the dependent variable here is x, so this is also linear. It doesn't matter about this t because t is independent variable in this case. Number 3, if we have d squared y dx squared plus y squared equals to 0, this is nonlinear. It's nonlinear because of the term y squared is nonlinear. So this, if you make the power to be 1, then it will be linear. number 4, dy dx plus sine of y equals to 0 is nonlinear since sine y is nonlinear. Variable, nonlinear function of the dependent variable. So that's how we do classification according to order. Thank you.